In this video, we're going to talk about permutations. We use permutations to count how many ways items can be arranged when no repetition is allowed. In other words, you can't use the same item over and over and over again, and when order matters. So going back to the picture at the beginning, if you can kind of envision all those little stick people that were there, you can't repeat people, all right? You couldn't put them in, couldn't repeat them. And the order would matter because I could tell the difference. If I moved those stick people around, I would be able to tell the difference based on the height, based on the colors, based on whether or not they had a little triangle skirt on or not. So order there would matter, okay? It's distinguishable. You can tell the difference. So let's look at an example here. And how many ways can 7 people sit in a row of 7 chairs? So as I do this problem, the way I really like to think about this is I like to actually envision those 7 chairs. And then I start thinking, okay, when it comes to that first seat, how many different choices do I have, or how many different people could I possibly say, I want you to sit in the first chair? And that answer would be 7 people. Once somebody sits down, okay, once that little person has sat down in that chair, I still have 6 people that I need to be seated. And so I have 6 options for how many people I would say to say, please go sit in that next chair. And then one person sits down. Then the next time I have 5 choices, then 4, 3, 2, 1. And this is one giant and problem. I need to sit the first person and the second and the third and the fourth, etc. And we learned in our video about independent and dependent events that and is a good indicator that we should multiply. So when we multiply all those numbers together, we will come up with a total of 5,040. Now, one thing I can tell you is there is a shortcut button, most likely on your calculator, that will calculate that for you without you having to type 7 times 6 times 5 times 4, etc., which you can do. It's not a problem. But anytime you start at one number and you continually decrease until you get down to 1, there is a button on your calculator. It looks like an exclamation point. This exclamation point is known as a factorial. And what that does is it starts at a number and then it continually multiplies by the next number down until you get to 1. You may use that button if you would like. So 7 factorial is how you would enter that. For some of you, depending on the calculator you use, you might see a factorial key. For some of you, there might be a button on your calculator that says PRB. And then when you press it, you get like 3 options, probably an NCR, an NPR, and a factorial. But again, it's not something you have to use, but there you go, all right? So let's look at the next one. How many ways can 24 gymnasts win the gold, silver, and bronze medals? Okay, so again, if we think of what's gonna happen here, we're awarding a gold, a silver, and a bronze medal. When it comes to the gold medal, there are 24 different gymnasts competing, each of whom could potentially win the gold medal. Once we've awarded the gold medal, you can't win 2. So there would be 23 options for who could win the silver medal, and then there would be 22 options for who could win the bronze medal. And again, since this is a and problem, we're awarding a gold, a silver, and a bronze, we will multiply those together and discover there are 12,144 ways we could award those 3 medals. Now again, there is a button on your calculator that will complete this calculation without you having to type it out. Although personally for me, having to type it out is almost faster than locating the key. But it was mentioned on the previous screen. The one you're looking for is the NPR button. And for most calculators, you would type 24, then you'd use your NPR button, and then you say 3, 24 being the total number of gymnasts we have competing, 3 being how many spots or how many medals we're going to fill, and that will give you the same result as what is up there. Again, for me personally, I rarely, if ever, use that button, but you are welcome to do so if that's what you want to do. If you're struggling to find that button on your calculator, best thing I can tell you is to Google your calculator make and model, and then write in permutations, and then you will be able to determine how your particular calculator works. All right, let's look at another one. How many ways can 5 friends sit in a row of 5 seats if Bob wants to sit on the end and Betsy wants to sit next to Bob? So again, thinking of what's happening, we have 5 different seats, okay? And we have something particular that's happening here. Bob wants to sit on an end, okay? So if this is Bob here, hi, I'm Bob, and Bob wants to sit on an end, Bob is either going to sit here in the first seat or down here in the last seat. That gives him 2 choices for where Bob is going to sit. So we're going to give him 2 options, okay? Now, this 2 does not mean I'm putting Bob in the first seat. It means I'm giving Bob 2 choices for where he sits, okay? Betsy wants to sit next to Bob. So once Bob has been seated, either here in the first chair or here in the last chair, how many choices would Betsy actually have? If Bob was seated here, Betsy will be essentially forced to sit in this seat. She has 1 choice, okay? If Bob sits down here in the end, again, Betsy essentially has 1 choice. She'd be forced to sit in this seat. So how many choices is Betsy really giving herself when she wants to sit next to Bob and Bob's sitting on an end? Well, she's giving herself 1 choice of where she sits. Okay, again, it doesn't mean I've put them in the first and second seats. It means this is how many choices, okay? Then we have 3 other people. We have no idea who this is, so we're going to call them random person 1, random person 2, and random person 3. Okay, random person 1, notice there are 3 empty seats. I don't know if they're the last 3 or the first 3. Doesn't matter. That person has 3 seats to choose from, and then they sit down. The next person, random person number 2, has 2 seats remaining, and then the last person only has 1 choice. Again, this is a giant and, so if everybody needs to sit down, we will multiply those together. There is no fancy button that's going to do that. Just go ahead and multiply, and you can probably do this one in your head and come up with 12 different ways that those 5 friends can sit in a row of 5 seats if Bob has to be on the end and Betsy wants to sit next to Bob. Last series of examples in this video. How many license plates are possible if there are 3 letters followed by 4 digits if repeats are allowed? Okay, so 3 letters, 4 digits. Repeats are allowed. Okay, so with letters, and that's what we know these have to be. These are letters and these are digits. There are 26 letters in the alphabet, and we get to reuse the letters, so 26 every time. For digits, there are 10 digits, 0 through 9, and again, we get to allow repeats all day long. And so multiplying all of that together, and the shortcut would be 26 to the 3rd times 10 to the 4th, we will find there are 175,760,000 different license plates that can be formed with 3 letters followed by 4 digits. Now, what if we don't allow repeats? Again, letter, and 4 digits. Okay, for the first letter, we'd have 26 options. But if you can kind of picture 26 Scrabble tiles in a bag, 1 for each letter of the alphabet, once you put a letter in the spot on the license plate, we're not going to put it back in the bag. There would then be 25 letters left in the bag from which you're drawing, and then there would be 24 letters left in the bag. Then if you kind of think of the same thing for digits, maybe you put in 10 chips or 10 tiles that have a 0 through 9 on them. You would have 10 choices for the first digit, but we're not going to put that tile back in the bag. Then there would be 9, 8, 7. Okay, so again, you can just multiply those numbers together. That's the tactic that I will take. It doesn't take me that long to find out what that value is. We get 78,624,000 different license plates. If you do want to use that NPR button, you can do that. That would be your 26 NPR 3 times 10 NPR 4. Got two separate ones, the letters and then the digits. But again, I just think it's simpler to have one method. So for me, that's the multiplication. All right, and then the last one, only vowels and even digits are allowed. So same scenario, but only vowels and even digits. So vowel, 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 even, 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 even. Okay, now anytime it does not specify that repeats are not allowed, we will assume repetition is allowed. Okay, that's just kind of one of those overarching things. So when it says vowels and even digits are allowed, and it does not mention that you can't repeat, we're going to assume you can. So for vowels, our vowels are A, E, I, O, and U, although I just wrote them backwards, but that's all right. A, E, I, O, and U. So there are 5 options every time I draw a vowel. Again, we're allowing repetition, so it's like drawing the letter out and putting it back in the bag. For even digits, our even digits are 2, 4, 6, 8. I'm still saying 1, 2, 4, 6, 8, and 0. 0 is an even number because to get to an even, you have to basically skip count by 2. So if you're starting at 2 and going down, it would be 0 and then -2, etc. So there are 5 even digits, and again, we are allowing for repetition. So in this case, this ends up being 5 to the 7th power, which gives us 78,125 various license plates comprised only of 3 vowels and 4 even digits.